Properties of ionic compounds. To learn about the properties of ionic compounds, let us perform the following activity. Activity. Take samples of sodium chloride, potassium iodide, barium chloride or any other salt from the science laboratory. The physical state of these salts is solid. Take a small amount of a sample on a metal spatula and heat directly on the flame. Repeat with other samples. Flame color after heat. Sodium chloride, yellow. Potassium iodide, light purple. Barium chloride, from pink to white. Try to dissolve the samples in water, petrol and kerosene. Sodium chloride, soluble in water, insoluble in petrol, insoluble in kerosene. Barium chloride, soluble in water, insoluble in petrol, insoluble in kerosene. Potassium iodide, soluble in water, insoluble in petrol, insoluble in kerosene. Make a circuit and insert the electrodes into a solution of one salt. Aqueous solution of sodium chloride, barium chloride and potassium iodide conducts electricity. Sodium chloride, barium chloride and potassium iodide nature is ionic. Melting and boiling points of some ionic compounds. Ionic compounds. NaCl. Melting point 1074 Kelvin. Boiling point 1686 Kelvin. Ionic compounds LiCl. Melting point 887 Kelvin. Boiling point 1600 Kelvin. Ionic compounds CaCl2. Melting point 1045 Kelvin. Boiling point 1900 Kelvin. Ionic compounds CaO. Melting point 2850 Kelvin. Boiling point 3120 Kelvin. Ionic compounds MgCl2. Melting point 981 Kelvin. Boiling point 1685 Kelvin. You may have observed the following general properties for ionic compounds. First, physical nature. Ionic compounds are solids and are somewhat hard because of the strong force of attraction between the positive and negative ions. These compounds are generally brittle and break into pieces when pressure is applied. Second, melting and boiling points. Ionic compounds have high melting and boiling points. This is because a considerable amount of energy is required to break the strong inter-ionic attraction. Third, solubility. Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Fourth, conduction of electricity. The conduction of electricity through a solution involves the movement of charged particles. A solution of an ionic compound in water contains ions, which move to the opposite electrodes when electricity is passed through the solution. Ionic compounds in the solid state do not conduct electricity because movement of ions in the solid is not possible due to their rigid structure. But ionic compounds conduct electricity in the molten state. This is possible in the molten state since the electrostatic forces of attraction between the oppositely charged ions are overcome due to the heat. Thus, the ions move freely and conduct electricity.